Okay, let me. And okay, let me share. I'll see. All right, can everyone see the presentation?
Yes.
Great. All right, well, hi everyone. Welcome to the Dapr community call for November 16, 2021. My name is Nick Greenfield and I'm a docs maintainer on the Dapr project, and I'll be the host for today's call. Before we get started, I just want to provide a quick reminder that the agenda for these community calls are open discussions on the Dapr community repo under the pinned issues section. So here on my screen, I'm on the Dapr organization with the community repo. We have today's call here pinned. And so you can see there's ongoing discussions about what it is what we will talk about and present. The next one can be found for November 30th here. And so I encourage you, if there's a topic around Dapr that you wish to learn more about, or maybe something that you'd like to show, you're working on something neat that you've built with Dapr, to provide your input here on this GitHub issue thread. And we'll work with a community call host like myself and others on the thread to finalize the agenda for that community call. So just a reminder that this is the place to go if there is something particular that you're interested in showing or learning more about. Okay, so let's get it back to today's call. So today we're going to talk about 5 different topics. We're going to start off with the exciting news of Dapr joining CNCF. Then we'll talk about the recent renaming of GA to stable components and what it takes to get a component to stable status. And then we're going to transition into the newly released AKS Dapr Extension. And we'll also take a look at Dapr's role in the new Microsoft PaaS offering, Azure Container Apps. And then lastly, George Stevens will share some insight into how you can streamline Dapr annotations for Kubernetes using Helm. And as always, everyone in this call is muted by default except for the presenters. So if at any point you have a question, please feel free to use the chat to ask your question, and we'll try to make sure to leave time in between these topics to address the questions. And if we're short on time, we'll try to get to it at the end during the open discussion. So without further ado, I think we can jump into our first topic, which is Dapr joining CNCF.
Okay, fantastic. So since its very inception, Dapr's goal was always to be donated to a foundation, and that was to provide the fact that Dapr, its goal has become vendor neutral, not controlled or owned by any one particular company or organization for that matter. And so we were thrilled that on the 3rd of November, Dapr got officially accepted into CNCF as an incubation project. And an incubation project shows a very large, significant level of maturity. If you're familiar with CNCF, they have Sandbox, which basically is early stage incubating, which has to demonstrate that it has customers running in production, it has a growing and healthy community, that it has a number of members that are active in the community, it has active governance around this all, and there's a fairly strict set of criteria. So the fact that Dapr got accepted as an incubation project shows its maturity as a project. And so we were thrilled effectively that CNCF have brought Dapr underneath their charter now. And you can go and read this blog post that they posted on the same day, giving a little bit of an outline and some of the quotes and some of the perspectives around from CNCF itself about why Dapr was an important project to them. And in particularly, Dapr brings a developer-centric focus into CNCF, which is wonderful because it then combines a lot with a lot of the infrastructure sort of centric technology that's there already. If you go and look at the CNCF project/Dapr, you'll see Dapr there as one of these projects now. And effectively over the next couple of weeks, a lot of behind the scenes work will happen so that CNCF will take control of trademarks, take control of domain names, and effectively have the full Dapr banner and all of its assets under its control. And so now, from that point of view, Dapr effectively is a CNCF project, and completely out of the hands of Microsoft or any of these other vendors, and we'll have a growing future inside this. So this is fantastic for the project, it's fantastic for the community, it's fantastic for the growth of Dapr, and we hope that now, at this point, Dapr will continue to grow. And I just want to say thank you for everyone who really made this happen, which is really, it wouldn't have happened without community members themselves actively being participants as a main criteria that CNCF focus on. So thank you for everything that you've done to here, and please continue to support Dapr, and we look forward to a healthy, long life with Dapr as part of the CNCF.
Awesome, thanks, Mark. I know I'm personally looking forward to seeing the Dapr dev stats that CNCF has. So it'll be really interesting to see all the metrics that they capture. Okay,
that's me.
So we're gonna hand it over to Archer and Phil to talk about how to promote a component to stable.
Hi, can you hear me?
Yep.
Can you go to the next slide, please? Okay, so people have been asking how many of the Dapr components are stable, which ones can be used in production, and we have that table available in our documentation. Another question is, okay, now how can I make a component stable? Which, by the way, it's a great contribution to the project. If you want to, if there's a component that you really like, really want to use, and it's not in stable mode yet, you can definitely contribute to components contrib repository by making a component stable. And what are the paths that can lead to that? So these are a very summarized version of it, and I'm going to go into more details after this. But first is make sure that the component can pass the conformance tests. So conformance tests are the ones that make sure the component can behave with the basic APIs of Dapr, the basic behavior of the APIs. So if you get state, if you save state, can you get the state? Can you save a state with integer, with a string, with a byte array? So these are examples of tests that are already written, but you need to make sure your component is configured to run as part of the automation as well. So that makes sure your component has a basic conformance test passing. At that point, you can even call your component beta. Then you get into the certification process for stable. You need to submit a certification test plan. So the certification test plan is basically going to be reviewed by maintainers to determine if that test plan is suffice to call the component stable. Once that is approved, you go to the next stage, which is implement the certification tests. So everything that you put in the plan, and now that you can implement in our repository and get that to be executed automatically as part of our CI/CD pipeline, but also as part of our release process. So this is a high-level summary of the 3 steps. And this is documented. I'm going to share my screen. Okay. Let me continue here. Give me a minute. Can you see my browser?
Yep.
Okay, thank you. So this is part of our documentation. It goes into detail about the certification life cycle, the overview, the levels, and I'm going to focus more on the process itself today. So the first step is to make it from alpha to beta, and the main difference here is to make sure it passes the conformance tests, right? So that's the biggest deliverable here. And then, of course, you submit a change in the docs repository, updating the components level from alpha to beta. Beta still allows breaking changes, okay? Now, from beta to stable, you have to, first of all, make sure that there will be no more breaking changes. So you have to be comfortable with the metadata that is available, the basic behavior of the component, and things like that. And the first step is to create an issue in components contrib for the certification test, okay? And the PR should contain a test plan. So once that passes, then the maintainers reviews the test plan, Then you submit the PR with the automated certification tests implemented. Of course, after that is all done and merged, you submit the docs PR calling that stable. So this is a high level of the overall process to make a component stable, and that is new. We have changed the process since 1.5, and we have moved to stable 3 new components as part of 1.5, adopting this new process. Okay, and this is an example of a test plan that we have for Kafka, and you can see that it goes into the details of like how big is the cluster, does it have partitions, sidecar, how many images, sorry, how many unique messages, does it validate the retry. He also has another test about workflow of publishing and subscribing, and then you keep account of how many were sent or received. So these are examples of scenarios. And another one that's very important is how do you test that the component can reconnect? So a stable component should not require the sidecar to be restarted for the client to reconnect and recover from an outage. So that is something that is validated as part of the test plan, and the maintainers will review that as part of your PR. So I don't want to go too much into details about the code. I think, Phil, are you ready to show some of the code for certification tests?
Yep, I'll spend just a few minutes on that. All right, so as Archer mentioned, in the repository, you'll find the testing plan right next to the code. And the way we are structuring these testing plans is almost like a written narrative that pretty much matches up right against the testing plan. So you can almost speak of it in terms of human language. So it's articulated like, okay, so if we're going to run Kafka in this particular example, in this test, we're using Docker to do that. So there's a Docker compose file that is told to bring up a 3-node cluster, and you can dig into you know, how they're configured and all that stuff in there, but not important. But it initially brings up that cluster, waits for the addresses to be able to be connected to. With most components, you need to do a little bit more to make sure that that actual platform is ready to be connected to and actual traffic to occur. So it actually tries to create a consumer and start consuming a particular topic. Once it can do that, you know that Kafka is ready, and then it starts the rest of the test. And so it'll bring up a application number 1, which we don't have to get into the applications per se, but there's kind of a one-to-one between an application running and a sidecar, because the sidecar obviously is using the application and vice versa. You can point the sidecar at a particular configuration. So this will allow you to test your component with any number of different configurations and settings that you need based on that particular component. You can set up how you want the sidecar to communicate with the application over HTTP or gRPC. You can configure all the ports. But importantly here, like this one little line is actually saying run it with just the one component I'm testing, and up above you'll see that it's loading Kafka, the Kafka specific component for PubSub. And so that's basically the kind of the running the sidecar, running the app. All this stuff is embedded inside of this test. So all of it's Go code basically at the end of the day. It still ends up exercising all the same code as if these were different containers, but it gives you some flexibility in terms of testing. Archer talked about counting the messages and making sure that they make it from publisher to receiver. All that is just made easier by the fact that all this is kind of one program with just different processes running in the background. And I'm not going to show you the code per se, but there are these little variables here. I call them consumer groups, but these are basically what we call watchers, which all they're really doing is doing that bean counting, making sure that every message that you anticipate sending is received on the other side, even despite the fact that there are Kafka brokers going up and down, or that there may be network interruptions happening all in the meantime, all concurrently with these applications running. And so you can kind of see examples here. We do basic send and receive tests. That's just making sure basically everything goes through and is being counted perfectly. And then we get into more sophisticated tests where we start sending messages in the background, and we start doing things like bringing down brokers, bringing them back up, making sure that the consumer groups recover, making sure that the publishers are then able to send again. And then we get into some of the network interruption stuff. So as you can see, what we've really tried to do is kind of like the spirit of Dapr is to provide building blocks for building applications. This flow and these steps, and they're composed of a basic building block we call a runnable. So we're trying to provide you building blocks to create these types of tests more easily. So in theory, you should be able to cut and paste this right into a new a certification test and be able to get this functionality for free. You just have to retrofit ports that you wanted to simulate blocking and turning off and things of that nature. So I'll let folks get into some of the individual runnables, but I just wanted to give you a taste of this stuff. And I think our documentation will improve on how these things behave and what they do over time. But this is kind of like the initial cut of this stuff, and think of it as a living document. It'll continue to evolve and expand and get better as we break into more different types of components and more scenarios that those components exhibit. So that is all for me.
Great. And Archer, you're wrapped up as well. You might be muted.
Yes, I'm done. Sorry, I was finding the unmute button.
No worries. Okay. Well, thank you both. Let me share my screen. Okay, I think everyone can see. So next topic is the Dapr AKS extension, and I will cover this one. So about 2 weeks ago during the Unite conference, the Dapr AKS extension was released as a public preview feature. So you can see here, you would use this extension through the Azure CLI using cluster extensions, which is something that you need to opt into. For more deep dive into how to use this extension, I provided these links up here, as well as a quick start into how to use this extension on a sample application. But ultimately, what this extension allows you to do, if you're working on an AKS cluster, it's the easiest method of installing and provisioning Dapr on AKS. And we do this, and this is done with smart defaults. So as you can see here, this command, like I said, is creating that extension and it's provisioning Dapr after a minute or two on your cluster. And it does this with high availability of the Dapr control plane enabled. So you can see the Dapr control plane here. Each of these resources is backed by three different pods. So and there are some other smart defaults that go into this as well. And the other big thing about this extension is that it helps manage the Dapr versions for you if you need it to. So you can opt in for automatic upgrades, and Dapr will take care of making sure when new releases come out, and it will auto upgrade you. Or if you particularly wish to stay on a specific version, you can provide that. You have that option as well as being able to roll back. Lastly, this extension does have support for all native configuration options. So as I mentioned, high availability, and I'll find the link and put it in this deck for all the other options that you have. I think it's in one of our repos, but you can provide those as configuration settings when you use the extension, and those will be applied to Dapr being installed on your cluster. And then lastly, this extension is supported. So, since it is an extension of AKS, you can expect similar support policies as other AKS features that are currently in preview. So this was released 2 weeks ago. I encourage you to check it out if you're developing with AKS. And yeah, open to feedback. Sorry, I should probably check, make sure there's some questions as we go. I'm not seeing any, so we'll keep going, and we'll move on to Will, who will talk about Dapr in Azure Container Apps.
Thank you, Nick. Apologies for the awkward camera angle. My regular webcam decided to not work at the last minute, so we'll power through this. So if you want to go to the next slide, please. Yeah, and like Nick, I'm very excited to announce the availability, the public preview availability of Dapr in Azure Container Apps. And for those of you who don't know what container apps are, it is a fully managed service to host your microservice applications as containers. And specifically for Dapr, what it offers is a fully managed version of the Dapr APIs. Fully managed, so you don't have to install Dapr or runs all the Dapr sidecars on your behalf alongside your container applications that you deploy. And some screenshots I included here are some of the sample from the sample in the link above. These are just example commands that you may use to deploy a container app, a Dapr enabled container app. Deploying a Dapr enabled app hasn't been easier. It's really simple. You deploy it with a Dapr enabled Dapr flag. You can configure components to it. You can define the app port and the app ID. And then you have your apps deployed, and you get all the benefits of a Dapr enabled app with container apps too. For example, the feature that I found to be most impressive was the built-in telemetry and via integrations with Azure Log Analytics and Azure App Insights, which I'll show you here in a little bit. Like AKS Container Apps, it is a fully supported Azure service. It's a fully managed Azure service, and you can expect a preview level of support for the features while they're in public preview. So I'll share my screen and kind of give you a quick run through of the App Insights capabilities or integrations. So give me 1 second here. All right, so this page is just the same link as the one in the slides, and it's the sort of the tutorial for container apps documentation for deploying a Dapr enabled application. And the specific application that I've already pre-deployed on container apps is the one in the example used here. There's two applications. One's a client, a Python client, and one's a service. So it's basically the for those of you who've looked at the Dapr quick starts, it's the Hello Kubernetes quick start. So you have this client that invokes the service. And when it invokes the service with some data, an order number, the order number gets stored into an Azure storage account here. So I've deployed this, and because it's on container apps, because it's Dapr, I've also been able to enable the application insights integration as well, which means I can get advanced telemetry about the apps that I've deployed. So this is everything I've deployed following this tutorial, and adding an additional step on my own of deploying an application insights resource and associating that resource to my container apps environment, which then will allow the Dapr sidecars on my Python app and my Node app to emit the telemetry into my application insights resource. So when you click into the application insights resource, you see some graphical representations of all the metrics that are flowing through from your application. But what I think is really nifty is this application map feature that you can use to visualize your services running. So right now, Python app should be calling Node app once per second, and it's been running since this morning. So it's got 3.5 thousand calls. and you see the calls to the state store that's configured as a component of Node app, a Dapr component, and all this is being facilitated by the Dapr sidecar. So if I click refresh, you'll probably see these numbers change, or maybe it takes a while for the numbers to plumb through. But basically, yeah, this is this architecture, but visualized in a nice application map with the telemetry built in as well. So all that you get with Dapr built into the container apps. So feel free to hop onto this link and explore and try it out for yourselves.
Cool, thanks, Will. I think we do have one question. Dimitri asked, I noticed that container app name duplicates Dapr ID. Is that always the case?
That's a good question. It's not always the case. You can name the container app a different name to the Dapr app ID, but Dapr app ID, as you all may know, needs to be the same as it's the app ID that you use for like service invocation. So you need to name the Dapr app ID appropriately, but it can be different to the container app name.
I believe if you do not specify the Dapr app ID as a param, it will use the container app name for that by default, right? You might fact check me on that, but could be wrong.
I'm not entirely sure about that, but we can check up on that.
Okay.
Yeah.
Okay. Well, thanks. So let me get back. Actually, I'll just hand it over to George Stevens. Are you ready to present?
Ready.
Cool. Awesome.
Okay. Can everyone hear me?
Yes, we can.
Okay, so this is about how to use Dapr annotations in your Kubernetes deployments when via Helm templates, name templates. And so I'll show this link here at the end of this if you want to see the whole thing. So getting on to the thing, basically when you have a manifest like here, that's a deployment for Kubernetes for this service A app, you have these Dapr annotations that you have to put in each service that's a Dapr A service, which means you've got to write this stuff over and over and over and over again. And you have to plug these values in, which are all different. All of this is the same, all of this is different. And I said, oh, this is too much trouble, too many errors. Why not just do something like this where I can just plug in the values enabled, the port number, the app protocol, the log level, and let Helm take care of all the hard work. And so I figured out how to do that using named templates. And so basically in Helm, each service deployment that you're using a deployment, here it's app A service or app service A. This is the template for that service. All you have to do is tell it when it gets down to the annotation section. So what to think is when you're looking at this and reading it, you're thinking that Helm is just emitting each line and it fills in the stuff inside the parentheses with the variables that are contained in Helm that you define or that Helm defines. And so here it comes down to here and it spits out annotations, then another line it spits out the Dapr app ID, and then it calls this in Dapr annotations include, which is a name template, which does all the hard work, and that's down here. So remember, we're including Dapr annotations, and here is Dapr annotations, a nice little Helmed template that is just what, 5 lines of YAML that this thing is going to output into the manifest that it's generating. And it uses the values from the values file. And the values file is down here. So it's going to put in enabled here. It's going to be true. It's going to put in the app port is going to be 3500. And Helm's going to put in HTTP for the protocol and so on. And then it's going to generate this part of the template from that above. And so that's basically it. You basically write your Helm template and you can stick it in your Helm script for the system you're producing, or you can turn it into a library template and it'll go live on your dev system forever and be available across multiple systems that you build. And if you want to see the code for this and a blog that goes into the grubby details, you can find it right here. So I'll be happy to answer any questions.
Cool. Thanks, George, for sharing that. That's really neat. Let me look here and see if there's any questions from anybody. Not seeing any, but at this point we have gone through the topics and we've moved on to the open discussion session. So if anyone has anything particularly with what we talked about today, feel free to ask that in the chat, or other topics that are top of mind regarding Dapr. We can use this time to go through those questions.
I got a question, George, on that you just showed. Did you do that because that Helm annotations because it helps speed up deployment in production and make it consistent? Is that the goal?
Yes, that's what I did. Why I did it. I want to have it consistent. I don't want to put a lot of work in. I want to reduce typing, reduce errors. And that's what it does. I might note, though, I did that about 6 weeks ago. Since then, Azure Container, or ACA, the one we just talked about, you don't need it for that, I don't think. And also the Kubernetes extension, you don't need it for that. And so really this will only be handy for deployments onto Kubernetes that aren't on Azure.
You would still need it for the AKS side, because the extension today is just, the purpose of that is to provision Dapr, the control plane, on your cluster. It's still up to you to annotate your deployments so that you have, it knows that to inject the sidecar and all that stuff. So
that's good to hear.
Yeah.
Okay, that's good. That's just good to hear. So you used it because it could just make sure your deployment pipeline particularly was consistent, and you can change it inside one file. Yeah.
Yes.
Good stuff. Excellent. Really good. And actually, could you post that URL in the chat window of your code?
Yeah, just let me go retrieve.
That would be useful, because then we can take that and we can make sure that yes.
Oops.
Okay, so George is posting that. Looks like we have another question in the chat. Some related to this topic. From what I can tell, the Dapr.io sidecar image notation in Kubernetes is not taken into account by the sidecar injector. I think we're going to need a little bit more clarification on that. So I will unmute you. If I can find you in the chat. Oh.
Hey, hello.
Hi.
My scenario is that I'm having a custom Dapr build, which I want to run in Kubernetes. And I wanted to sidestep building all the other images and giving Helm my custom images for all the Dapr components. I just wanted to plug in the sidecar, the custom sidecar component, since I only affected the Dapr with my custom code. And I first tried this, but it actually makes sense that it doesn't work, because you want to have all components be the same version as each other, right? So I cannot plug in any sidecar image to replace just the sidecar code.
Oh, I see. So your scenario is that you've built your completely different Dapr D image
Yes.
that you want to run yourself, and it's your own custom version of it. But you can't run that and the sidecar injector doesn't allow you to run that inside and launch it?
It doesn't seem to take effect. It uses the official image if I plug in that annotation. And I didn't see it used in code, so I'm guessing it skips what you put in that annotation.
Charlie's just replied to you, and I remember now. So,
yeah, so there is a way to do this. It's not particularly well documented because it's not super encouraged to do this, but it sounds like you know what you're doing, right? But there is a parameter, and I think I correctly remembered it from memory, but I have to go look, that allows you to specify the sidecar image URL or sidecar image path to download an arbitrary sidecar to get the injector to download an arbitrary sidecar. And so what you're doing can be done, just, it's one of those do at your own risk kind of things, right?
But
Charlie, there is a new feature where the annotation will also do that. So if you install Dapr 1.5, you should get this feature. If it's not working, please, that is a bug as well that we need to fix.
well, right now I'm working on 1.4.3. So,
Oh, that's probably why you have to use 1.5.
okay.
When you say feature, you're talking about this, and you're talking about the thing that Charlie just talked about. Yes, Arthur?
Yeah, the annotation. Yeah, the annotation is a new feature in 1.5.
Yes. So there's a new, so inside 1.5, there's an annotation that you can have for the Kubernetes that allows you to specifically pull in the sidecar image that you want to run.
Yes, sure, and then that will override the sidecar image. The sidecar image environment variable parameter that Charlie's pointing out for the sidecar injector, that still works. You can still do that as well. But in 1.4, that's the only one available. In 1.5 onwards, you can also do via annotation.
Okay, cool. Thanks.
Okay, thanks for the question. Any other questions, since we still have a little bit of time? I can always unmute you if you just ask to be unmuted in chat. Okay, I'm not seeing anything, so I want to thank everyone for the discussion today and presenting the topics. Again, I highly encourage you for the next community call to, again, if there's something that you wish to show and tell, something neat that you've done with Dapr, we really want to hear about it. So you can use the thread on the community repo to post your idea, or if there's something else that you are specifically interested in learning about, again, that's another thing that we're open to. So please use those GitHub issue threads for that discussion. So thanks everyone for attending today, and we'll see you in the next one.